Hello and welcome to A-Level Physics. My name is Paul Lovett and I'm your lecturer for the two-year A-Level Physics programme. We also have an option for AS Level Physics, which is completed in 1 year. Physics is the kind of subject that you want to study if you're going to go on to do engineering or any of the applied sciences. Physics is now very big in medicine. Physics is for the curious. It's for those who are eager to learn about the fundamental nature of the laws of the universe. We study the very tiniest particles. So in the very first year, we study particle physics, atomic and particle physics. We look a little bit at quantum mechanics. And in the second year, we'll take the astrophysics unit, which will look at the very largest structures in the universe, all the way out to the galactic scales, clusters, and superclusters of galaxies, all the way out to the edge of the visible universe. You'll deal with the smallest numbers, such as the mass of the electron, all the way out to the biggest, the dimensions of the universe. So numeracy is one of the most valuable traits of any physics student. Your scientific literacy is also the reason why physics students are, and in fact any science student are, extremely valuable to employers. You will learn an enormous amount of technical and scientific vocabulary, and to succeed on this course you will also learn how to explain and describe really quite complex ideas using that correct terminology. So apart from numeracy and literacy, what else do physics students possess? They possess extremely highly developed practical skills. We do our 12 set practicals, but many more than that. You'll probably do an experiment, I would say, on average at least every other week during the 2 years. So your hands-on equipment, including data logging, your hands-on equipment handling is going to be of the highest order. You're going to be able to record data, process data, and draw conclusions. And that again makes you a very valuable student. I personally am very keen on my spreadsheet, so you'll do an awful lot of modelling using Excel, and over the course of the 2 years, although you do need to draw a graph by hand, you will also learn a lot about how to use spreadsheets. Course content, we go through the usual forces and motion, dynamics, energy, momentum and turning moments in the first year. Electricity is a large part of the course, as is waves, which I think I might say is my favourite part of the syllabus. We do a little bit of material science, Hooke's law and Young modulus, and as I said before, we do look down at the atomic and particle scale, so the very smallest things that exist, and the standard model of particle physics. In the second year, we develop our knowledge of forces and motion. So we look at circular motion, simple harmonic motion, your pendulums and your masses on springs, which are very much connected to ideas of circular motion. We'll go into thermal physics and ideal gases, where we'll derive the ideal gas laws. Electromagnetism is a massive part of the second year. And we'll also expand on our knowledge of nuclear physics with Einstein's famous E=mc² equation. We finish the course by looking at astrophysics, which brings in topics of lenses and telescopes, and also the structure of stars, how they maintain their equilibrium, the life cycle of stars, which you might have studied at GCSE, and the large-scale structure of the universe. How do we know what is out there from looking at it? And you'll be surprised how much you will have learned at this stage that will help you to understand exactly how we know what we know about the universe. Requirements are your usual suite of GCSEs. We do like to see a 6 in English, and especially we will be requiring 6s in maths and sciences or physics. We do prefer you to study A-level maths alongside your physics qualifications, so grade 7s are preferred by the maths department. It is a 2-year course and it finishes with 3 exams, a total of 6 hours of exams. In terms of extracurricular activities for science and particularly physics students, we do run a science club after college. That would normally be on a weekly basis. It's not running at the moment because of COVID, but certainly we'd like to get that back up and running as soon as possible. Trips are on hold at the moment, but we do every year go to the Science Museum and the National Natural History Museum in London. We will arrange a visit as soon as we're able to the Rutherford Appleton Laboratory, which is in Oxfordshire. It's the UK's particle accelerator, and you can stand on top of that facility that you see in the photograph there with neutrons, protons in fact, whizzing beneath your feet at 98% of the speed of light. You can see a lot of concrete there to protect you from the radiation. They have laser and neutron facilities at Rutherford. There is also a yearly trip to CERN in Switzerland. You will have all heard of the European Centre for Nuclear Research, and there is a proposal to take a group to Chernobyl in the Ukraine. We do every year try to organise the Sparshot Experience Day. Now it's of interest to us as physics students because they've got an electric horse, and you can sit on that wearing all sorts of sensors, and those sensors report your exact movements to the computer software, and you'll be able to have a look at how sports performance is analysed in the equine setting. So I try to reserve that for the physics students when we go there. Thank you very much. There is a practical competency certificate which comes with the course, and certainly intended that everyone acquires that. If you do want to hear from Paul and Jess, 2 outgoing grade A students now studying engineering, then we will provide you with a link to our Mahara pages where they will give their personal testimonials on their success on the course and the way it's taught. I look forward to seeing you at some point for one of our open evenings or open days, and hopefully we'll get that will happen in the coming months. And look forward to seeing you studying A-level physics at Andover College.